Hello, our dear student for the third preparatory stage. I wish you interest studying science. Science is very important for our mental development. Let's start our session today, which is talking about the second unit, which is called mirror and lenses. In this session, we will explain how does mirror reflect the light rays. First lesson is talking about mirrors. Before we studying mirrors, we must know what's meant by light reflection. Light reflection is a phenomena of returning back or rebouncing of light ray after hitting a reflecting surface in the same medium. This is the incident light ray, which is incident on the reflecting surface. It will reflect and become reflected ray. This is the perpendicular line. The incident angle is the angle between the incident light ray and the perpendicular line, while the reflected angle is the angle between the perpendicular line and the reflected ray, all meet at the point of incidence on the reflecting surface. What's meant by the incident light ray? It is the light ray that falls on the reflecting surface. Angle of incidence of the light ray is the angle between the incident light ray and the perpendicular line to the reflecting surface at the point of incidence. What's meant by the angle of reflection of the light ray? It is the angle between the reflected light ray and the perpendicular line to the reflecting surface at the point of incidence. What's the laws of light reflection? Laws of light reflection is the first law, the angle of incidence equal the angle of reflection. The second law, the incident light ray, the reflected light ray, and the perpendicular line from the point of incidence on the reflecting surface all lie on the same plane perpendicular to the reflecting surface. Here there is a question which is give reason for. The incident light ray falls perpendicular on the reflecting surface, it reflects on itself. Why, when the incident light ray falls perpendicular to the reflecting surface, it will reflect on itself? This is because the angle of incidence equal the angle of reflection equal 0. There is no angle of incidence, so there is no angle of reflection, so the value of them equal 0. Mirrors. Mirrors, they are the reflecting surface of light. Mirrors is a surface which reflects the light rays after falling on it. What are the types of mirrors? Mirrors have many types. Number 1, the plane mirrors. Number 2, the spherical mirrors. The plane mirrors found in all our homes. The spherical mirrors, they are concave mirror and convex mirror. Firstly, we will talk about the plane mirror. The plane mirror is a piece of plain glass painted from behind with thin layer of silver metal to give the glass a bright surface that reflects most the incident light rays on it. This is the definition of the plane mirror. What are the properties of the image formed by a plane mirror? Number 1, upright image. Number 2, reversed. Reversed equal laterally inverted. Equal in size to the object. Virtual. Virtual means can't be received on a screen. When we measure the distance between the object and the mirror, we find it equal to the distance between the image and the mirror. The straight line joining the object to its image is perpendicular to the mirror surface. These are the 6 properties of the plane mirror image. Give reason for. The word ambulance is written laterally inverted. We see the ambulance car in the roads with the word ambulance written laterally inverted. That's because mirror forms laterally inverted image so the drivers can see word corrected. Spherical mirrors. The spherical mirrors whose reflecting surface is part of a hollow sphere. Types of spherical mirrors: convex mirror, concave mirror. The concave mirror is called the converging mirror because the reflecting surface is the inner surface of the sphere, which is colored by the blue color. This is the reflecting surface of a concave mirror. This is. While the convex mirror is called the diverging mirror. The reflecting surface is the outer surface of the sphere, which is colored by the blue color. This is the outer surface of the sphere and the reflecting surface of the mirror. Some concepts related to the spherical mirror. Number 1 is the center of curvature of the mirror. The center is the center of the sphere that the mirror is a part of it. The abbreviation of the center of curvature is C. The center lies in front of the reflecting surface of a concave mirror. It lies in front of the reflecting surface of a concave mirror, while it lies behind the reflecting surface of the convex mirror. The radius of curvature. Number 2, the concept of the radius of curvature. It is the radius of the sphere that the mirror is a part of it. From the drawing, we see that the radius is the distance between C and X, or C and P, or C and Y. They are the radius of curvature. Another concept, which is the pole of the mirror. The pole of the mirror is the point in the middle of the reflecting surface of the mirror. Here is the pole of the mirror, found in the concave mirror and the convex mirror. Another concept, which is the principal axis. The principal axis is a straight line that passes through the center of curvature and the pole of the mirror. Any straight line which passes through the center of curvature and the pole of the mirror is called the principal axis. Another concept, the secondary axis. The secondary axis is a line that passes through the center of curvature of any point on the surface of the mirror except the pole. This is the principal axis. This is the radius. This is the convex mirror, concave mirror, the pole of the mirror, center of curvature. This is the radius, or maybe the secondary axis, which pass with the point C and any point in the circle except B. The focus. The focus is the point of collection or intersection of the reflected rays when these rays fall parallel to the principal axis. The focal length is the distance between the focus and the pole of the mirror. The focal length equals half the radius of curvature. Each spherical mirror has uncountable secondary axes, but only has one principal axis, the concave mirror. The focus of the concave mirror. This is the concave mirror. This is the principal axis, lies on it the center of curvature. In the midpoint between the center of curvature and the pole of the mirror, we find the focus. This is the incident light ray which reflected after hitting the reflecting surface of the concave mirror and collected at a point called the real focus. The real focus is produced due to the collection of the reflected rays emitted from a far object. Some rules for light rays meeting the concave mirror. This is the concave mirror. The principal axis lies in it the center of curvature and the focus of the mirror. This is the incident light ray, which incident parallel to the principal axis. This ray, when hitting the reflecting surface of a concave mirror, it will reflect passing through the focus. Another rule. This is the concave mirror, and the principal axis lies on it the center of curvature and the focus of the mirror. If the light ray passes through the focus of the mirror, it will reflect parallel to the principal axis after hitting the reflecting surface of the concave mirror. Another rule. What happens if the light ray falls incident passing through the center of curvature of the mirror? It will reflect on itself. If the light ray passing through the center of curvature of the mirror, it will reflect back through the point C as reflect on itself. The path of light reflected from the spherical mirror. The first case, which is this is the concave mirror and this is the principal axis. If the light ray is coming from far object, it will reflected and collected at a point is called the focus. The position of the object is very far, like the sun. The position of the image is formed on the focus. What is the properties of the image formed? Real and very tiny. The second case. This is the reflecting surface of the concave mirror, and it is the principal axis joins between P and C passing through the F. The object lies after the center of curvature. It will send a light ray, falls on the reflecting surface of the concave mirror. This light ray will reflect passing through the focus of the mirror. Another ray which is passing through the focus, which will reflect parallel to the principal axis, so the image is formed between the center of curvature and the focus. The position of the object at distance greater than the radius, at distance more than double the focal length. The position of the image at a distance greater than the focal length and less than the double the focal length. What is the properties of this image? We see that this image is inverted. We see the image inverted and dimensioned. Another case, this is the concave mirror. That's the principal axis which passes through center of curvature and the pole of the mirror. The object lies on the point C. This object will send a light ray which passes parallel to the principal axis. This ray will reflect passing through the focus. Another ray sent by the object which is passing through the focus, so it will reflect parallel to the principal axis. The image is formed on C again. Where the position of the object at a distance equal to the radius, or at the center of curvature, or at a distance equal double the focal length. The position of the image at a distance equal double focal length. What are the properties of the formed image? The formed image is formed real, inverted, and equal in size. Another case, the concave mirror. This is the principal axis which passing through the center of curvature and the pole of the mirror. In the midpoint we find the focus. The object lies between the focal length and the center of the curvature. The object will send the first light which is parallel to the principal axis. This light ray will reflect after hitting the concave mirror, passing through the focus. Another ray sent by the object which is passing through the focus, which reflect parallel to the principal axis. In the point of intersection of the two reflected rays, we find the image. The image properties is inverted. We find it bigger than the object or magnified. Real. Why real? Because it is the point of it formed at the intersection of the two reflected light rays. The position of the object at distance less than the radius, or less than double the focal length and greater than the focal length. Position of the image at distance greater than double the focal length or after center of curvature. Properties of the formed image: real, inverted, magnified. Another case, this is the concave mirror. This is the principal axis which passes through the center of curvature and the focus of the mirror. Here the object will lies in the distance smaller than the focal length, and it is very nearer to the concave mirror. This object will send a light ray parallel to the principal axis which reflect passing through the focus. The another ray will reflected on the center of curvature, which will reflect on itself. So by take the extensions of both the two rays, the image is formed in the another side of the mirror or behind the mirror, and the image is found to be upright, magnified, and virtual. The position of the object at a distance less than the focal length or between the focus of the mirror and the pole of the mirror. The position of the image behind the mirror. Properties of the formed image: virtual, upright, and magnified. We found that the image which is real always inverted and formed in front. Properties of the formed image: virtual, upright, magnified. We see that the real image always formed in front of the concave mirror and always inverted, but the virtual image formed behind the concave mirror and always upright. What is the uses of concave mirror? We can use the concave mirror in solar ovens to collect sun rays and generate heat that cook food without fuel. Also, in marine lighthouses to guide the ships. In shaving to get enlarged and erect image of the face. In torch to reflect light. In airports, aircrafts to guide aeroplanes. This is the experiment to determine half the radius of the concave mirror. What is the material used to make these experiments? Number 1, a concave mirror, a holder for the mirror, light box with a hole. What is the steps? These all the materials we use. This is the concave mirror, the holder, and the light box. Place the mirror on a holder in front of the light source. Move the mirror nearer and farther until an image of the hole is formed next to it and it equal to it in size. Measure the distance between the mirror and the hole. It will be equal to the radius of curvature of the mirror. We deduce that the focal length of the mirror equal radius division 2. The convex mirror. The convex mirror formed image can't be received on the screen or a virtual image because the incoming rays diverge after reflection. Properties of the formed image by a convex mirror. Wherever the position of the object in front of the convex mirror, the image is. This is the convex mirror and the principal axis. The object will be stand at any distance from the reflecting surface of the convex mirror. This object will send a light ray that is parallel to the principal axis and another ray which is passing through the focus. These rays will diverge and then we take the extensions, so the image is formed behind the convex mirror. This image is smaller than an object, upright, virtual, can't be received on a screen. The uses of convex mirror. Convex mirrors can be used as a side view mirror in the car because it forms an erect, smaller image for the way behind the cars. Also, we can use convex mirror to expand the visibility because it formed virtual small erect image. Used in turning of the roads and parking. Formation of the focus by convex mirror. This is the light rays which incident parallel to the principal axis of the convex mirror. These rays will diverge. These rays will be diverged after falling on the reflecting surface of a convex mirror. After take the extensions of the diverged light rays, the focus is formed, which is a virtual focus. It is produced due to the collection or intersection of the extensions of the reflected rays emitted from a far object. We reached to the end of our session today. I hope you understand and interest studying with me. Goodbye. See you later in the next episode.